So yes, hello everybody. This is my first ever video, and this would be the tutorial for bi-weekly contest 166. Just FYI, this contest is still going on. Don't worry, I will post this video after the contest ends only. So yeah, I was able to solve all the four problems again in under 30 minutes. We can see here, and secure currently ranked 369 all over the world. I am assuming there would be around 100 cheaters, so around 250 I should be able to get. Yeah, pretty good performance. Overall, the contest was quite easy, and like the pattern were there were a lot of questions that were like following some patterns. So yeah, let's start with the first problem. Quite an easy problem. So yeah, let's go. And yeah, I would discuss my solutions in this video. Again, there could be many easier solutions to this, and if you know any easier solution to this, just let me know in the comments below. So what does the first problem say? You're given a string s consisting of lowercase English letters. The frequency group for a value k is the set of characters that appears exactly k times in s. The majority frequency group in the is the frequency group that contains the largest number of distinct characters. So what this question basically says is, let's say I have a string A, B, B, C, D, A. So here A occurs two times, B occurs two times, C occurs one time, and D occurs one time. Now for 2, there are two elements that occurs two times. That is 2 has A and B occurring two times. One has C and D occurring one times. So so this is the frequency group of 2, and this is the frequency group of 1. Like CD is the frequency group of 1, and AB is the frequency group of 2. So what is the question then saying? Return a string containing all the characters in the majority frequency group in any order. If two or more frequency group tie for the larger size, pick the group whose frequency k is larger. So yeah, here we can see that both 2 and 1 have two elements, but uh, because 2 has more frequency, so 2 is greater than 1. That's why the answer for this string would be AB. So we need this majority frequency group. So yeah, this is quite easy. I didn't even look at the constraints. We can, yeah, constraints are also very light. Like you can go up to n cube. Again, you don't need to. So what I did was a simple implementation. I got the string size, so that I stored it in n. I got the frequency of all the characters in the array in this frequency vector. So yeah, this is boilerplate kind of code. Then in this map, what I did is store the all the like for. So what this does is basically for each frequency, like for 2, I have to store that string that has all those characters, like this string basically. So this 2ab1cd kind of string, this I will store in my map. So this would be my map. Here mp of 2 basically would be ab, and mp of 1 basically this frequency group would be cd. Yes. Okay, this we can close this tab. So yeah, I just stored all for all the characters their frequency group. So frequency of I is the frequency, and ch is the character that has that frequency. Then in the answer variable, I got the I want to show the answer, so I did over this map, and if the frequency is greater than 0, and the string size is greater than, oh, okay, so why do we need this if f is greater than 0? Because this MP2 and 1 makes sense, but MP of 0. So what would be MP of 0 is basically all the characters in the string that have 0 frequency. So that would be all A to Z minus just A, B, C, D. And this would be here the biggest, but we don't want this. So frequency has to be greater than 0 for it to be considered in the element in the answer. So yeah, if frequency is greater than 0 and the this size is greater than equals to answer, we just do answer equals to 2. Why is this greater than equals to? Because the question says that if if two or more frequency group tie for the largest size, pick the group whose frequency k is large. And because we are storing it in map, the frequency would be sorted by frequency. So basically, MP of 0 would be first, then MP of 1, then we will iterate over MP of 1, then iterate over MP of 2. Hopefully, this makes sense. It's a very easy problem. I think my explanation went a bit longer. So if you are getting confused, just try to code this out. It should be easier. Like go step by step, like try to create this frequency, then try to see, okay, how can we use this frequency to get the, like how can I show that what characters have frequency of 2, like all those characters, and then how to use those characters to get the answer. I think I'm over explaining myself. We can go to the next question. Like this is like, I think if you have solved like even 5 or 10 DP questions you should be able to solve. This is like the most pattern DP question out there. So what the question says, you are climbing stairs with n plus one steps. Okay. Oh my bad. Okay. Yes. So what the question says there, you are climbing stairs with n plus one step numbered from 0 to n. You are given an one index. So yeah, this is kind of important. At a cost of the length j, cost of length n, where cost I is the cost of step I. For from step I you can only jump from, so from I you can go to I plus one, you can go to I plus two, or you can I plus three. And the cost of jumping from I to I plus 1 would be cost of j. So basically that would be costs of basically where you are going, I plus 1, plus the delta between these two, the j minus I, that would be 1. And for this would be cost of 1 square basically, which is 1 only. So costs of I plus 2, the delta here, or basically I plus 2 minus I is 2, so 2 square. And similarly here, costs I plus 3 plus 3 square. So this would be the cost from going from I to. And what you need is you start from you start 0 with cost equals to 0, return the minimum cost of to reach step n. Like this you can easily solve. We are just creating a simple DP relation, that DP of j equals to minimum of DP of I plus, or rather, just give me 1 second. Yes, dp of j minus 1 plus 1 square plus dp of j minus 2 plus 2 square plus dp of j minus 3. Oh, sorry, this should not plus, this should be common because we are doing the minimum. Alright. So it's my first video, please. I'm not that good right now. dp of j minus 3 plus 3 square. Yeah. So all you need to do is this. We can just go over the code. I create this because we need to go from 0 to n. So that's why I created a vector of n plus 1 size. So, and I initialized everything to int max. Now it is said that you are at step 0 with cost 0. So dp of 0 equals to 0. Then you go over from I equals to 0 to I is less than equals to n. This we can keep, even this is fine, but for the sake of simplicity we can do this. Now d I, because it is like from dpi you can go to dpi plus 1, I plus 2, or I plus 3. So that's why this loop is 3 times. So basically what I'm saying is, if you are at I, kind of like a bfs traversal, if you are at I, we will calculate the value for I plus 1, for I plus 2, and for I plus 3, like these three values. So that's why I'm doing d equals to 1 2 3 traversal here. Now, if you are doing d amount of jumps, you will arrive at I plus d. And if this is a valid state, like it's not beyond the, it's not like n or n plus 2, like you can do some like amount of change. I just did this, like just keep this in an if statement. So if this j is less than equals to n, just use our dp relation that we just found out. The dp of j should be minimum of already computed value, and the value that you will take if you are going from dp of I. So what would be the cost, like why we did this j minus 1 would is just that cost is in one indexing and you need it in zero indexing. Does this make sense? Yes. Okay. Yeah, I think this is pretty explanatory, simple solution. It's a very patternic problem. I think we should go to the next question. Distinct point. Okay, so this also I think is a patternic problem, but you need a little bit of intuition to solve this. Again, I think it's pretty easy and straightforward. Let's go over question 3 now and see what it is. You are given a string S. Sorry. You are given a string S and it only has these four characters: U up for up, D for down, L for left, R for right. Representing moves on. So yeah, U is this, that X Y to move X Y plus 1, that is up. This is right. Okay, I'm not autistic. I got my pen right down. Right. Sorry. D is down and L is left. So yeah, from XY, these would be your four coordinates. You are given a positive integer, okay? You must choose and remove exactly one continuous substring of. So exactly is a very important word here. because if it said that you can remove at most one, but that the question would change. I think the solution, you just need to do a couple of changes, but the it would remain the same. Continuous substring of length k from S, then start from coordinate 0, comma 0 and perform the remaining moves in order. Return an integer denoting the number of distinct final coordinates reachable. So what this question says is that you have like 0, comma 0. If you have something like U, D, L, R, D. So if you just do this 5 instructions, you will go up, then you will come down, you will go left, you will come right, and then you will go down. So you will land at, this would be 0 comma minus 1. So this would be your final coordinate. Now it says that you are allowed, you have to remove, let's say k equals to 2. So you have to remove a substring of size 2. So you can remove these two, or you can remove these two, or you can remove these two, or you can remove these two. So you can remove, you can get at most one, two, three, four removals, right? Let's say if we remove this two, so I get LRD. So for LRD, I will go left, I will come right, and I will go down. So that would get me to 0 minus 1. Let's say I remove this DNR, so I get URD. So that is I go up, then I go right, then I come down, and that is 1 comma 0. So this and this are the two distinct. So my answer is currently at 2. Then let's say I remove this, let's say I remove this. So now I get UDD. That is, I go up, then I come down, then I come down, and then my answer, this is 0 minus 1. Now this is not distinct, right? This and this are both same, so my answer would remain at 2. And so far you have, and then you can try removing this string and see where you end up. Okay. So what we need to do is just get this answer, number of distinct final coordinates reachable. So how to solve this? The first thing that you can think of is like doing brute force. Eh? What will be the time complexity of brute force? So brute force is that you go over all the strings, so that all the case of strings, like starting from 0, then starting from 1, then starting from 2, all those strings, that would take you n time, and then after removing, you get construct the rest of the string, and then for rest of the string, find the final coordinate. That would take again n time. So that would give you n square time complexity. And if I take a look at the constraints, s is 10 to the power 5, so n square would become 10 to the power 10, and that would again clear you. So how to make this easier? What you need to see is that if I have two strings, let's say one is u d d l, and another is u, rather d l d u. Let's do both of this: up, down, down, left, right, and at minus 1 comma 0. Let's do this: down, left, down. Oh, okay, sorry, down, left. I'm here, so down and up. Again, I end up minus 1 is comma 0. So does the order matter? Order of these characters does not matter, right? Obviously it doesn't matter. You go up now, or you come, or you go up 10 minutes later, or 10 moves later, you're still going up the same amount of time. Order doesn't matter. What matters is like my up frequency, my up frequency matters, my down frequency matters, my left frequency matters. So the frequency or the count of all these characters matter. Right frequency matters. So how can we use this thing? How can we exploit this thing? I always think of what is the minimum amount of stuff I need to know, and how can I calculate this very fast. So now, if let's say I have this array u d l l r d u with k equals to 3, how can I use this fact? So can I calculate the total frequency of, let's say u? I calculate the total frequency of u is 1 and 2, right? Let's solve for only like calculating u frequency. Okay. So I calculate the total frequency of u as 2. Now I calculate k equals to 3. For these three characters, I know that there's only u equals to 1. How can I calculate the amount of u in this array, I can do a prefix for u. Then I can do a prefix of L. So what I'm trying to get is that I will go over all these like this thing. Uh, okay, I give me a second. Yeah. So what I'm trying to say is I have to go over all the n substrings. So go over all n substrings. All n substrings basically meaning first we'll go over this substring, then we'll go over this substring of all n substrings of k size. This would be like n minus k actually. Then go over the this substring, go over this substring. And for going over all the substrings, calculate L frequency, R frequency in the subarray, and so on. D. So on for D, so on for U, right? And then get the so all these frequency would get removed, right? Remove these from total frequency. So what you will get is, let's say I am going over this array. I have the U D L L R D U. So for this for this one, right? Yeah. DLL is for DLL. D has frequency of 1, L has frequency of 2. Now I remove these two from the total frequency of UDLR. So the total frequency of U is 1, 2, D is 2, L is 2, R is 1. So when I remove this, U will have frequency still of 2, D will have frequency of 1, L will have frequency of 0, and R is frequency of 1. So using this, can I not calculate my final coordinate? My final coordinate would be, but I'm going up twice and coming down once. So my y coordinate would be 1, and I'm going right once. So that would be 1. So I just need to do this thing. Hopefully, I make sense. I'm over explaining everything. The code is quite simpler. Let's go over the code. So what I create is a set of pair int comma int reachable. So this would have all the distinct points that I can reach. Then I calculate the string size. Then I calculate dx dy. So what is this dx dy? Is this that rather than storing up frequency and down frequency, I can up frequency and d frequency. I can just create a dy. When I encounter d, I would dy plus dy minus minus, because these are counter interactive to each other, right? If you go up, then you come down, so these will cancel each other out. So for d, you just need to do dy minus minus. For up, you need to do dy plus plus. That's the idea here. So vector in dx and dy. So this is like the prefix sums for this, right? So you calculate this prefix sum. If you are so you get the for prefix sum of I, that would still have prefix sum of I minus 1. That is what we're doing here. Then if you are doing going up, you do dy plus plus. If you are going down, you do dy minus minus. And if you are going left, you do dx minus minus. And if you are going right, you do x plus plus. That makes sense. Now the total x and the total y, that is the reachable when you do not remove anything. That is this total x, and that would be the dx dot back and dy dot back. Now this is what I'm showing, that I will go over all the substrings, but I will calculate the final coordinate in O of one time. How we can do this is that I go over all the substrings, then I find the endpoint of the substring, and I calculate the total prefix of that. So this is similar to how you calculate this. Let's say if you have 2, 3, 5, 6, 7, and someone says to you, okay, calculate me this sum 3 to 5, then how will you do this? One thing is you can just go over this, or the other thing is that you can calculate the prefix sum. That would be 2, 5, 10, 16, 23. Then if you want this, you will get the sum of 10. So you have to calculate from I to j. That would be prefix sum of j minus prefix sum of I minus 1. That is what we are doing, right? That is how you calculate the prefix sum. of I to j. So, oh, so rather sum of I to j. So that would be 10 minus 2i, right? That is what we are doing. It's quite simple. Rx is basically you do this. If I is greater than 0, you remove the dx I minus 1 and I dy minus minus 1 and then x and y. So that is the x and y right now after removing the k substring wala thing. So x would be tx minus rx. So rx is basically the amount of x that you are removing, the amount of up x or down x you are removing, and ty minus iy, and then you can insert this in a reachable array in the reachable set. And because it's a set, it won't contain any duplicates, and then you can just return the reachable dot size. Hopefully this makes sense. Again, I'm over explaining things. It's my first video. Please bear with me. Final question. This question was kind of interesting, and I don't think it's that patternic, but it, it is kind of patternic. I think so. Like once I got an idea how to solve it, I solved it really quickly. I just needed to code it out. So let's see what the question says here. You are given an integer. Yes, you are given an integer array nums. You want to maximize the alternating sum of nums, which is defined as the value obtained by adding elements at even indexes and subtracting elements at odd indexes. That is nums is 0. So this is an even indexes. So you plus this. This is an odd index. You do minus, plus, minus, and that is why this is alternating, because you do plus, minus, something like that. Right. So you are given a 2D index integer array swaps where swaps I equals to pi to qi. For each pair pi qi in swaps, you are allowed to swap the elements at indexes pi and qi. These swaps can be performed any number of times and in any order. Return the maximum possible alternating sum. So maximum possible alternating sum. We can go with the questions as well. So yeah. Constraints are that n, which is the nums dot size, is 10 raised to the power 5. Num size 10 raised to the power 9. Swaps dot length is this. So it's quite high. Like you can't go n square or beyond. How do you solve this? So first thing that should come to your mind is, let's say I have my array nums, right? Let's say this is 1, 2, 5, 3, 4. Let's say you can rearrange this array anyhow, and you want the maximum alternating sum. How will you rearrange this thing if you can swap any element with anyone? What you will say is that for alternating sum, for odd indexes, so for even indexes I get plus. So this is like plus minus plus minus plus. So can I say my alternating sum is like my even sum minus odd sum? Right, that's true, right? Here the even sum would be 1 plus 5 plus 4, and odd sum would be 2 plus 2. Okay, so even sum minus odd sum. Also, my even sum plus odd sum would be a constant. Hey, that's a total sum of nums, and total sums of nums we cannot change. We are not changing the value of nums. That's why this is a constant. So what you will say? Let's try to maximize the even sum. My in, odd sum would always get minimum, because if let's say this is getting increased, this would have to decrease, because sum has to be constant. So we should try to maximize even sum. So to maximize even sum, or you can say, or let's say minimize odd sum. Both means the same. These two are the same thing. So how you can do this is you can sort this array, and then I will get 1, 2, 3, 5, 4. At all the even indexes, I should put the maximum value. So that is, I should put 3, 5, 4. I should put 3 here. I should put 5 here. I should put 4 here. And at the odd index, I should put the smaller value. So 2 and 1. So 1 should come here, 2 should come here. And then I would get that my thing is 3 plus 5 plus 4 minus 1 plus 2. Right? This would be my maximum alternative sum. If you can identify this, this problem becomes very easy, because now you can break our problem into this problem. How you can do this? Look at the swaps operation. Okay. And then look at graph. Can I use graph here? How? Do we know how to solve the number of islands problem? What is the number of islands problem? That I'm given a graph here. Let's say this 0, 1. Rather, let's keep it undirected there. 0, 1, 2, 3, 4, 5, right? And all I need is the number of connected components here. So this is a one component connected component, this is second connected component, this is third connected component. So this thing plus my number of islands, number of islands is all we need. This is a major hint. Now you should try to solve this question. Okay, let's get back into how to solve this. So what would be the island in our case? Let's say we still have this array 1, 2, 5, 3, 4. You are said that you can swap 2 and 3. So that is 0, 1, 2, 3, 4. 1 and 3 you are allowed to swap. You are allowed to swap 2, rather, this would be 0, 2, 0, 2, and let's say 2, 4. Right. So can I say that my 1 and 3 are in the same connected component? Because let's right, because one's value can come to 3, three's value can come to 1. That's why how swap works, right? Similarly, 0, 2, 0, 2, and 2, 4, right? Now can I say that zero's value can come to 4? Yes, it can. 0 can swap with 2, 2 can swap with 4. Makes sense? So these connected components can actually, any value can be swapped with anything in one island, or you can say a connected component. I am going to use island here. In one island, each, every value can come anywhere. Other, every value can be swapped or can come other can sorry can come anywhere. If this is true, haven't we solved this problem already? We solved this problem. We saw how to solve it. Every value can come everywhere. You just have to maximize at an even sum. And how you can do this? Become greedy. Put the maximum value at the even index. If this is done, this question is done. We can just go over the code now. So what I did is I again got the n, that is the nums.size. I created my adjacency vector, which you go over all the swaps, you get the p and you get the q, and you add this edge from p to q and q to p to keep it a bidirected edge. Then you create a visited thing. So this visited would be used for the for island thing, because if I don't need to. I don't think I should explain how you do the number of islands problem. So all you need to do is this: go over all the indexes. If this is already visited, continue. If it is not, you should call this sort island. So how the sort island works is this: it would first get the island. It would get all the values in the array, and then it would put the correct values in the correct slot to get the maximum alternating sum. So how what we do is this in the sort island is I do a simple BFS, and I got get all the values, and I get all the odd indexes, and I get all the even indexes, and then I sort all the values. So what I'm trying to say is what we did here, right? How did we solve this problem? I get all the odd indexes, that is 1 and 3. I get all the even indexes, that is 0 to 4, and I get all the values sorted. So that is 1, 2, 5, 3, or the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now for all the odd indexes, I put the smaller values. For all the even indexes, I put the bigger values. That is simply what we are doing here, right? So for all these smaller values, that is, if j is less than m, I should put a smaller value here. Else I can put the bigger value. J equals to answer. And after putting all the correct values, I can just calculate what my answer would be. So I am putting using the greedy solution on the island, and in the island, all values can come anywhere. And how we saw how to solve this. So now we just need to go over the nums finally after doing all the swaps, and if it's an even index, minus it, minus its value, else adds value, and yeah, you can just simply return this. So that was my first video. I think it was quite messy. Like I couldn't collect my thoughts quick enough. It's my first video. Please stick by me. I think I can do better. Yeah. So yeah, this was a good contest. Thank you for watching. Bye bye. Jesus Christ, I have social anxiety.